Good morning, students. The next topic is electric currents in conductor. We are going to discuss the mechanism of flow of electric current in solid conductor. What we are going to discuss? Very simple thing. We are going to discuss mechanism of flow of electric current in solid conductor. Okay? Very simple thing. Electric currents in conductor. We are going to discuss mechanism of flow of electric current in solid conductor. What we are going to discuss? We are going to discuss mechanism of flow of electric current in solid conductor. In solid conductor, you know very well the charge carriers are free electrons. सॉलिड कंडक्टर में जो भी करंट है वो करंट किन की वजह से है? दैट इज ड्यू टू फ्री इलेक्ट्रॉन्स. वेरी सिंपल थिंग. इलेक्ट्रिक करंट्स इन कंडक्टर. व्हाट टाइप ऑफ कंडक्टर? वी आर गोइंग टू डिस्कस सॉलिड कंडक्टर जस्ट लाइक metals and in metals you know the current is mainly due to free electrons. करंट जो भी है करंट किन की वजह से? दैट इज ड्यू टू फ्री इलेक्ट्रॉन्स. ओके फाइन. Now let us see, before this, all of you know kinetic theory of gases. I want to recall you your first year knowledge, kinetic theory of gases. In kinetic theory of gases, what happens? You will take one container. In that container, when you see the random motion of gas molecules, how the molecules will move? The molecules will move in a particular path or random motion. Because of this random motion, they will collide with each other. When they will collide with each other, inside a container, there will be a temperature increase. Because of this increase in temperature, they gain a thermal velocity. What velocity they gain? Thermal velocity they gain. They have thermal speed, but their average thermal velocity is zero. Why their average thermal velocity is zero? Because 1000 atoms will move in a particular direction. Another 1000 atoms will also move opposite to that. So cancel हो जाते. They may have thermal speeds, but their average thermal velocity is zero. Why? थोड़े few atoms क्या करते? 1000 atoms A डायरेक्शन से आते हैं और few thousand atoms क्या है? अपोजिट डायरेक्शन से मूव होते. बिकॉज ऑफ रैंडम कोलिजन व्हाट हैपेंस? their average thermal velocity is zero. Why we are using the word thermal? Because of their random collision, heat generated, and hence the molecules will get which velocity? Thermal velocity. The same thing is there here also we are using. Okay, very simple thing. First of all, we are taking one conductor. Okay, let us see. Imagine yourself, this is on solid conductor, no electric field is applied. We have one solid conductor, no electric field is applied. At that time what happens? Whatever free electrons are there, they start moving in a random motion. When they start moving in a random motion, they collide with neighboring free electrons. When they collide with neighboring free electrons, heat generates, and hence temperature inside a conductor increases. At the time free electrons gains thermal velocities. For example, if 1000 electrons are moving from left to right, on an average another 1000 electrons will also move from right to left. 1000 electrons, they are moving from left to right. On an average 1000 electrons also move from right to left. In this way they cancel each other. On an average thermal velocity is zero. When average thermal velocity is zero, the net flow of electrons is also zero. Net flow of electrons is also zero. This का मतलब क्या है? Current is also zero, and hence we can say whenever electric field is not applied to a solid conductor, current flowing through that solid conductor is zero. No current is flowing through that solid conductor. The same thing is you can see in figure 1. What kind of motion you can see? You can see the zigzag motion of the electron. This electron follows particular path or zigzag path. In our yesterday's basic concepts, we discussed that whenever you want to get a current through a conductor, the electrons should follow in a particular direction. That particular direction we will get whenever we are applying electric field. Electric field apply करने के बाद electrons will move in a particular direction. We are successful after applying electric field. We can send electrons in a particular direction, and hence some current we can get through the conductor. So electron should move in a particular direction to absorb the current, to constitute the current through the conductor. But here electrons are moving in a particular path or random motion, zigzag path. इधर उधर. जैसे मार्केट में जो है ट्रैफिक वाले नहीं है. Simple example है in our daily life what we are saying. Whenever you go to market, there is no traffic police person whose duty is to control the traffic. When he is not there, we will ride the bike randomly. हम सब लोग क्या करते हैं, बाइक जो है रैंडमली ड्राइव करते हैं, कार जो है रैंडमली ड्राइव करते हैं, थोड़े 500 लोग इधर से आते हैं, थोड़े 500 लोग उधर से आते हैं। वी मे हैव आवर स्पीड बट एवरेज वेलोसिटी इज 0। तो सेम थिंग है यहाँ पे इलेक्ट्रिक फ्लूइड बोलते जस्ट लाइक ट्रैफिक पर्सन। what you have to assume electric field means just like a traffic person who controls the flow of electrons, who sends the electrons in a particular direction. When no electric field is there, no traffic person is there, we will ride our vehicles in a particular direction or random motion. Because of that sometimes we collide with our friends or collide with other vehicles also. Accident may also takes place because of random collision. अगर हम लेफ्ट से राइट से सिस्टमेटिक जा रहे बोले तो अच्छा है, हम जब हम रैंडम से zigzag पाथ में जा रहे बोले तो कोलिजन हीटिंग होने के चांसेस ज्यादा है। वही यहाँ पे भी होता है। जब भी फ्री इलेक्ट्रॉन्स रैंडम मोशन में जाते कोलाइड होने के बाद टेम्परेचर क्रिएट होता है इनसाइड ए कंडक्टर। बिकॉज ऑफ दिस टेम्परेचर इलेक्ट्रॉन्स गेन्स थर्मल वेलोसिटी। ऑन एन एवरेज देयर थर्मल वेलोसिटी 0। दे मे हैव थर्मल स्पीड्स, concentrate my words, they may have thermal speeds but on an average their thermal velocity is 0. Why? For example, 500 electrons will move from left to right, another 500 will move from right to left, and hence they cancel each other. Their average thermal velocity is 0 and hence net flow of electrons is 0. When net flow of electrons is 0, current is also 0 because I is equal to Q by T. जब इलेक्ट्रॉन चलने के लिए तैयार ही नहीं है, when electrons net flow of electrons is 0 means no electron is ready to move and hence current flowing through the conductor is 0 when no electric field is applied for solid conductor. That's what we are going to see. When no electric field is applied on a solid conductor, the free electrons move due to their thermal velocities. The free electrons will be in random motion. This point is very, very important. The free electrons are in which motion? Random motion within the conductor. Due to the random motion, the free electrons collide with positive ions or atoms. ये random motion की वजह से जो भी free electrons है, they will collide with positive ions or atom and hence undergo change in direction at each collision. Therefore, they will change the direction in a particular path or zigzag path. एक बार hit हो गए, direction change हो गया. यहाँ पे एक atom और molecule है, और एक बार यहाँ पे एटम और पॉजिटिव आयन है, यहाँ पे और एक बार डायरेक्शन चेंज हो गई. नाउ वी हैव अनदर एटम्स और पॉजिटिव आयन बिकॉज इन सॉलिड कंडक्टर हाउ इट इज क्लोजली पैक्ड. यू नो इन सॉलिड कंडक्टर्स हाउ इट इज क्लोजली पैक्ड. Solid conductors means it is closely packed. Whenever electron collides with this atom, definitely there is a change in its direction. बाद में फिर और एक बार change हो गया direction. ये direction continuously change होते जा रहा है. We are not observing any particular direction. When we are not observing any particular direction means electron follows zigzag path, random path, and hence their average thermal velocity is 0. How? 500 electrons move from this direction, another 500 electrons will move on an average. We are saying on an average, another 500 electrons will move from this direction. थोड़े इलेक्ट्रॉन्स इधर से आते हैं, थोड़े इलेक्ट्रॉन्स इधर से आते हैं, and hence on an average net flow of electrons is 0. Whenever we are saying net flow of electrons is 0 and hence current is also 0. That's what we are saying. You see, when no electric field apply नहीं करे यहाँ पे. Are you seeing anything here, any external source? No. That's why we are saying no electric field is applied on a solid conductor. The free electrons move due to their thermal velocities. The free electrons will be thermal velocity क्यों होते? Because these free electrons collide with neighboring atoms at the time temperature increases and hence free electrons gains thermal velocity. हीटिंग की वजह से अपने पास वेलोसिटी गेन कर रहे. ये कॉन्सेप्ट आने के लिए आप काइनेटिक थ्योरी ऑफ गैसेस में कंटेनर में गैस मॉलिक्यूल्स देते हैं. These gas molecules will follow which path? The random path. Because of colliding with each other, they gain thermal velocities due to the random motion. This is very, very important. Random motion, zigzag path. Random motion means zigzag path. The free electrons collide with positive ions or atoms, undergo change in direction. Why the path has been changed? This electron hit to this atom. Definitely the path has to be changed. जब भी आप vehicle drive करते हैं, सामने कोई आए तो आप path क्या करते हैं? Change करते हैं. Okay? Whenever you are riding a bike on the road, you hit to some vehicles, some pole, light pole. At the time you have to change your path or not? Definitely the same thing happens whenever electron hit to positive ions or atom, the path will be changed. You are not observing particular path, you are not observing specific path, you are not observing preferential direction, you are not observing preferential direction, you are not observing particular path, you are not observing specific path, you are observing zigzag path, random path. Okay. Now the average thermal velocity is 0. Why average thermal velocity is 0? Because random motion, and hence what we can say, few electrons, let us take 1000 electrons will come from left to right on an average, और एक 1000, 5000, 10 electrons क्या आते हैं? Right to left आते हैं, and hence their average thermal velocity is 0 because velocity is a vector. प्लस माइनस कैंसिल ईच अदर, ऑन एन एवरेज देयर थर्मल वेलोसिटी जीरो। वही बात बोले यहाँ पे, द एवरेज थर्मल वेलोसिटी, वी आर सेइंग द वर्ड एवरेज, the average thermal velocity is zero because of random motion. The free electrons in the conductor do not move in specific direction. Of course electrons are moving, electrons are moving in zigzag direction, they are not moving in particular direction, because whenever you want to get current through a conductor, the basic thing is what, the electrons should move in a particular direction. खाली मूव हुए तो इधर उधर मूव हुए तो जो है इलेक्ट्रॉन्स हमारे को करंट नहीं मिलते। हमारे को करंट मिलना कंडक्टर के थ्रू बोले तो इलेक्ट्रॉन शुड मूव इन ए पर्टिकुलर डायरेक्शन, दे आर मूविंग, बट हियर वी आर नॉट ऑब्जर्विंग दैट इलेक्ट्रॉन्स विल नॉट मूव इन ए पर्टिकुलर डायरेक्शन इनसाइड द कंडक्टर. Okay, therefore the net flow of electrons is zero. This point you have to concentrate. Net flow of electrons is zero inside the conductor. Inside the conductor, net flow of electrons is zero, and hence current flowing through that conductor is also zero. That's what you can see in figure 1. Okay, now what we have to do in the next case 2, let us apply electric field. How to apply electric field? Very simple. Is it solid cylinder? Let us consider one cylindrical shape of conductor. Let us consider one cylindrical shape of conductor. We have end A, we have end B. We have end A, we have end B. यहाँ पे हम क्या करेंगे, यहाँ पे एक सर्कुलर डिस्क, I will take some circular disk A, I will take similar circular disk A of some dielectric material. I will take two disks of same dielectric material. I will take two circular discs of the same dielectric material. I will fix them on end A. I will fix another circular disc on end B, and I will give positive charge for end A. I will give negative charge for end B, and hence I am successful in setting the electric field. End A is maintained at positive charge, end B is maintained at negative charge, and hence electric field is set up in the conductor. तो क्या कर रहे हैं और एक बार सुनो. दिस इज ए सॉलिड सिलिंड्रिकल शेप ऑफ कंडक्टर, एक सिलिंड्रिकल शेप ऑफ कंडक्टर है. वी हैव एंड ए, वी हैव एंड बी. यहाँ पे एरिया ऑफ क्रॉस सेक्शन है, यहाँ पे भी बी है एरिया ऑफ क्रॉस सेक्शन. यहाँ पे एक आउटसाइड से एक सर्कुलर डिस्क ले रू मैं, यहाँ पे फिक्स करूं और एक सर्कुलर डिस्क ले रू, सेम डाइलेक्ट्रिक मटेरियल. ए एंड बी आर द टू circular discs of the same dielectric material. I will fix one circular disc at end A. I will fix identical circular disc at end B. I will give positive charge at A. I will give negative charge at B, and hence we are successful in setting a electric field. ऐसे पॉजिटिव चार्ज और नेगेटिव चार्ज मेंटेन करने से हमारे को इलेक्ट्रिक फील्ड यहाँ पे सेटअप होता. When electric field is set up inside a cylindrical conductor, what happens? The direction of electric field is there from positive charge to negative charge. The direction of electric field is there from positive charge to negative charge. That's what you are going to see in figure 2. Figure 2 में क्या है? There is a solid cylinder. There is a solid cylinder, and here we fixed one circular disc. Here also we fixed one circular disc whose radius is same as that of cylinder. Okay, बहुत simple है. यहाँ पे समझने की बात क्या है? We have one cylinder. We have one cylinder which possesses two ends A and B. यहाँ पे हमारे को एक सर्कुलर डिस्क फिक्स करना है, यहाँ पे भी सर्कुलर डिस्क फिक्स करना है. द रेडियस ऑफ द सर्कुलर डिस्क इज इक्वल टू द रेडियस ऑफ सिलेंडर. द रेडियस ऑफ द सर्कुलर डिस्क वी आर गोइंग टू फिक्स इज सिमिलर टू दैट ऑफ रेडियस ऑफ सिलेंडर. वी वांट हाउ मेनी आइडेंटिकल डिस्क? वी वांट टू आइडेंटिकल डिस्क ऑफ द सेम डाइलेक्ट्रिक मटेरियल. You want two identical discs of the same dielectric material of same radii as that of the cylinder. वो सर्कुलर डिस्क का रेडियस कितना रहना? That radius is equal to radius of the cylinder. You take one circular disc, fix at end A. You take another circular disc of the same radius, fix at end B. Now you give positive charge at end A. Now you give negative charge at end B as shown in figure 2. Positive charge maintained at this end, negative charge is maintained at this end, and hence we are successful in setting a electric field. ऐसा मेंटेन करने से हमारे को पोटेंशियल डिफरेंस मेंटेन हो रहा. एक तरफ प्लस क्यू है, एक तरफ माइनस क्यू है, एंड हेंस वी आर सक्सेसफुल इन मेंटेनिंग ए पोटेंशियल डिफरेंस. व्हेनेवर वी मेंटेन पोटेंशियल डिफरेंस, इलेक्ट्रिक फील्ड इज सेट अप. आपको मालूम है बेसिक थिंग. व्हेनेवर वी आर मेंटेनिंग ए पोटेंशियल डिफरेंस एट टू एंड्स, definitely there exists a electric field. This direction of electric field is from positive charge to negative charge. You can see the direction of electric field is from positive charge to negative charge. Because of this electric field, electrons will drifted towards positive charge. Why electrons should move? Because of electric field, electrons will move in the same direction of electric field or opposite to the direction of electric field. The electrons will move opposite to the direction of electric field. Nature ही वैसा है. The nature is like that only. The direction of electric field is always from positive charge towards negative charge, but electrons will move from negative to positive, means opposite to the direction of electric field. How electrons will move? The electrons will move opposite to the direction of electric field. Whenever electrons will move from opposite to the direction of electric field, these electrons will neutralize positive side. ये electrons move opposite to the direction of electric field and they will neutralize positive charges. Okay, whenever they neutralizes means what happens here? Electrons are in motion. Electrons चलने लगते हैं. क्यों चलने लगते हैं? उनका फंक्शन क्या है? न्यूट्रलाइज करना कोशिश करते हैं. These electrons will try to cancel the positive charges. That's why they move opposite to the direction of electric field. Nature ही वैसा है. The direction of electric field is from positive and to negative. The electrons will move from negative to positive, means opposite to the direction of electric field. That's what yesterday we said. Electron current is always from lower potential to higher potential. Nature of electron current कैसा है? Lower potential to higher potential. That's why they cancel positive charges on this end A. This means the electrons are in motion and hence they constitute a current. But this current is not a permanent. This is for short time. ये करंट परमानेंट नहीं है. दिस इज फॉर शॉर्ट टाइम, थोड़े वक्त के लिए है. कब तक? जब तक इलेक्ट्रिक फील्ड रहता. हाउ लॉन्ग दिस करंट एग्जिस्ट? हाउ लॉन्ग दिस करंट एग्जिस्ट? दिस करंट एग्जिस्ट अप टू इलेक्ट्रिक फील्ड एग्जिस्ट इनसाइड ए कंडक्टर. जब तक इलेक्ट्रिक फील्ड इनसाइड ए कंडक्टर रहता तब तक ही करंट रहता. This means the current flowing through this conductor in second case is for a short time. It is not a permanent. Let us see what happens. Consider a cylindrical conductor and two identical discs of dielectric having radii equal to that of cylinder. Put the charges plus q and minus q on the two discs and attach them to two ends of the cylinder as shown in figure 2. हम एक सिलेंडर लिए, सिलेंडर में एंड ए है, एंड बी है, यहाँ पे एक सर्कुलर डिस्क बिठा है, यहाँ पे एक सर्कुलर डिस्क बिठा है ऑफ सेम डाइलेक्ट्रिक मटेरियल एंड हुज रेडियस इज इक्वल टू द रेडियस ऑफ द सर्कुलर डिस्क इज इक्वल टू रेडियस ऑफ सिलेंडर. The radius of circular disk is equal to radius of the cylinder. Okay, the radius of circular disk is equal to radius of the cylinder. We have one cylindrical shape of conductor. We have end A, we have end B. End A में circular disc लो, end B में भी circular disc लो of same dielectric material whose radius is equal to that of cylinder. Fix at end A, fix at end B. Now give charge at end A positive charge and end B को negative charge, and hence we can maintain a potential difference developed across the ends of the conductor. When you give end A plus Q, when you give end B minus Q, इसको end A बोलो and इसको end B बोलो. When you maintain end A plus, when you maintain end B minus, we can develop a potential difference. Because of this potential difference, electric field is set up inside a conductor. Because of electric field, what will be the direction of electric field? The direction of electric field is from positive charge to negative charge. The direction of electric field is from positive charge to negative charge. Because of this electric field, electrons will move opposite to the direction of electric field and they neutralize charges on it and A. They neutralize which charges? Positive charges. Because electrons are negatively charges, when they move towards positive and definitely they neutralize positive charges. When they neutralize means electric field is zero. जब ये न्यूट्रलाइज बोले तो यहाँ पे पॉजिटिव चार्जेस क्या है? डिसअपियर हो गए. डिसअपियर हो गए तो इलेक्ट्रिक फील्ड विल नॉट एग्जिस्ट नो लॉन्गर. व्हेन इलेक्ट्रिक फील्ड विल नॉट एग्जिस्ट नो लॉन्गर, इलेक्ट्रॉन्स विल नॉट मूव एंड हेंस लेटर करंट बिकम जीरो. दैट्स व्हाई दिस इज ए लॉन्ग टाइम करंट और शॉर्ट टाइम. द करंट फ्लोइंग थ्रू द कंडक्टर इन दिस केस इज फॉर ए शॉर्ट टाइम. Due to this, a potential difference is developed across the ends of the conductor. Then electric field will be set up in the conductor and its direction is from positive to negative. Due to this electric field, the electrons will accelerate towards. इलेक्ट्रिक फील्ड का डायरेक्शन क्या है? पॉजिटिव टू नेगेटिव. डायरेक्शन ऑफ इलेक्ट्रिक फील्ड इज फ्रॉम पॉजिटिव टू नेगेटिव, बट द इलेक्ट्रॉन्स विल एक्सेलरेट टुवर्ड्स opposite to the direction of electric field means they accelerate towards negative to positive. इलेक्ट्रिक फील्ड का डायरेक्शन पॉजिटिव एंड से नेगेटिव है. इलेक्ट्रॉन्स विल एक्सेलरेट. व्हाई इलेक्ट्रॉन्स आर एक्सेलरेटिंग? कौन है एक्सेलरेट करने वाले? इलेक्ट्रिक फील्ड है. दीज इलेक्ट्रॉन्स विल एक्सेलरेट अपोजिट टू द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड फ्रॉम अपोजिट ऑफ डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, दैट इज मीन्स नेगेटिव टू पॉजिटिव. ड्यू टू दिस इलेक्ट्रिक फील्ड द फ्री इलेक्ट्रॉन्स एक्सेलरेट टुवर्ड्स प्लस क्यू. किन के तरफ जा रहे हैं? पॉजिटिव चार्ज की तरफ जा रहे हैं. जाने के बाद क्या होते हैं? न्यूट्रलाइज होते हैं. ओके, neutralize on the charges on the disk. Okay, the free electrons flow as long as there is electric field inside a conductor. How long these free electrons will flow? कब तक free electrons वैसे ही flow होते हैं? जब तक इलेक्ट्रिक फील्ड एक कंडक्टर के इनसाइड रहता है. हाउ लॉन्ग फ्री इलेक्ट्रॉन्स विल फ्लो? द फ्री इलेक्ट्रॉन्स विल फ्लो थ्रू द कंडक्टर. हाउ लॉन्ग? अप टू इलेक्ट्रिक फील्ड एग्जिस्ट इनसाइड ए कंडक्टर. As long as free electrons are in motion, current is there. जब free electrons रुक गए, there will be no free motion of the electrons. When electrons are not ready to flow, then I value is 0. That's why this is a short time current. This is not a permanent. Current flowing through the conductor in this case is for a very short time. We fail to maintain steady current. Constant current हमारे को maintain करने के लिए longer time possible नहीं है. We can observe current flowing through this circuit, or in this case is only for a shorter time. Okay. Due to this electric field, the free electrons accelerate towards plus q and neutralize the charges on plus q. इधर से electrons, ये electrons positive charge की तरफ गए. These electrons when move towards positive charge, definitely they neutralize because electrons are negative. यहाँ पे क्या है? Positive. Plus minus they will cancel and neutralize us. Okay. The free electrons flow as long as there is electric field inside a conductor. In this situation, there will be a current for short time. This point you try to understand. In this situation, whatever current you are going to see through a conductor, that is for short time and no current thereafter. Why there is no current thereafter? As soon as electrons migrate towards positive side, they nullify it, they neutralize it. When they neutralize it, electric field disappears. As soon as electric field disappears, there is no further motion of free electron. When there is no further free motion of free electrons, current is also zero. That's why in this situation we can see current flowing through the conductor for a short time. After that there is no current. Why there is no current? इलेक्ट्रिक फील्ड ही नहीं रहता. इलेक्ट्रिक फील्ड क्यों नहीं रहता? ये इलेक्ट्रॉन्स पॉजिटिव चार्ज की तरफ जाके, इलेक्ट्रॉन्स पॉजिटिव चार्ज की तरफ जाके, इलेक्ट्रॉन्स पॉजिटिव चार्ज की तरफ जाके क्या करते हैं? नलिफाई करते हैं, न्यूट्रलाइज करते हैं. न्यूट्रलाइज करे तो वहां पे इलेक्ट्रिक फील्ड क्या होता है? डिसअपियर होता है. व्हेन इलेक्ट्रिक फील्ड डिसअपियर्स, there is no net flow of free electrons and hence current flowing through the conductor is zero. Now question arises, we want to see through this conductor steady current. हम ये कंडक्टर के जरिए स्टेडी करंट ऑब्जर्व करना चाहते हैं. We want to see conductor through this conductor steady current. हम steady current flow करना चाहते हैं. We want to maintain steady current through this conductor. We want to maintain steady current through this conductor for a longer time. थोड़े देर के लिए हम एक steady current means whose magnitude remains same with a function of time. Maybe 10 second, 20 second, 30 second, 1 hour तक magnitude of current remains same. That type of current we call steady current. What is steady current? Magnitude of current should not change with a function of time. Time change हो रहा है लेकिन magnitude of current उतना ही आ रहा. For example 10 second में भी 5 ampere था, next 5 second में भी 5 ampere, next 15 और इसे function of time, magnitude of current remains same. That type of current we call steady current. If you want to maintain steady current flowing through this conductor, better two ends of this conductor connect through a battery. दो एंड्स है, ये एक एंड है, ये एक एंड है. एंड को किससे मेंटेन करना? सेल और बैटरी से मेंटेन करना. प्लस माइनस, सेल और बैटरी मीन्स प्लस माइनस. करो, यू सी दिस डायग्राम. Now what you are observing? This is a solid conductor. One end is connected to positive terminal of battery, another end is connected to negative terminal of battery. This end is connected to positive terminal of battery. This end is connected to negative terminal of battery. Now you can see the direction of current. Which current? This is the direction of conventional current. That's what yesterday we discussed. Because the direction of conventional current is always from positive to negative. But electron current is from negative to positive. Electron current is from negative to positive. But the direction of conventional current, यहाँ पे I जो बता रहे हैं, this I is the direction of conventional current from positive to negative. In this way, we can maintain which current? Steady current. When you connect it through a battery or cell. That's what we are saying. In order to maintain a steady current in a conductor, a continuous flow of charges is required. Continuously charges flow होना. Second case में क्या हो रहे थे? थोड़े देर के लिए electrons फ्लो हो रहे थे जब तक इलेक्ट्रिक फील्ड है. जब इलेक्ट्रिक फील्ड नहीं है, इलेक्ट्रॉन्स क्या हो रहे थे? फ्लो नहीं हो रहे थे. लेकिन एक केस में कंटिन्यूस फ्लो ऑफ चार्जेस फ्लो होते हैं. When this is possible, if the two ends of the conductor are maintained at different potentials. To maintain this potential difference, you connect two ends through a battery or cell. Okay. To maintain a potential difference across a conductor, we can use a cell or battery. Okay. यहाँ पे बैटरी है. Okay. हम क्या करना? स्टेडी करंट मेंटेन करना है. इफ यू वांट टू मेंटेन स्टेडी करंट थ्रू दिस कंडक्टर, बेटर टू एंड्स ऑफ द कंडक्टर मेंटेन दैट डिफरेंट पोटेंशियल. एक पोटेंशियल डिफरेंस जो है मेंटेन करना बाय कनेक्टिंग वन एंड थ्रू ए पॉजिटिव टर्मिनल ऑफ बैटरी, अनदर एंड टू ए नेगेटिव टर्मिनल ऑफ बैटरी, एंड हेंस वी आर सक्सेसफुल इन मेंटेनिंग ए स्टेडी करंट थ्रू द कंडक्टर. How can we maintain steady current through the conductor? By connecting this conductor to a battery. बैटरी में दो टर्मिनल्स रहता है, एक पॉजिटिव टर्मिनल रहता है, एक नेगेटिव. वन एंड को पॉजिटिव टर्मिनल दो, अनदर एंड को नेगेटिव टर्मिनल दो, and hence we are successful in maintaining a steady current through the conductor. That's what you can see in case 3. Figure 3. In order to maintain a steady current in a conductor, a continuous flow of charges. रुक रुक के नहीं, continuously electrons क्या होना? Flow होना. उसके लिए हम पोटेंशियल डिफरेंस मेंटेन करना. टू मेंटेन दिस पोटेंशियल डिफरेंस, बेटर यू कनेक्ट बैटरी और सेल विद द कंडक्टर. वन एंड इज कनेक्टेड टू पॉजिटिव टर्मिनल ऑफ बैटरी, अनदर एंड इज कनेक्टेड टू नेगेटिव टर्मिनल ऑफ बैटरी, एंड हेंस वी आर सक्सेसफुल इन मेंटेनिंग ए स्टेडी करंट एज शोन इन फिगर 3. Okay, this is the direction of conventional current type. This is the direction of electrons. This is electron current, lower potential to higher. This is the direction of conventional current, higher potential to lower. Of course, they are opposite to each other. This is I. What is I? In all the circuit diagrams, we are saying I means the direction of electric current, that is from positive to negative, and this is I. Steady current we can maintain. Steady current means magnitude of current should not change with a function of time. Constant current, for example, 100 milliamps, 100 milliamps, 100 milliamps. Before 5 minutes also we are getting 100 milliamps through the ammeter. After also we are getting 100 milliamps. After half an hour also we are successfully getting 100 milliamps through the ammeter. Okay. This type of current means magnitude of current should not change with a function of time. Magnitude of current remains same. That type of current we call steady current. Quickly you see case 1. What happens in case 1? No electric field is applied. No electric field is applied because of random motion of electrons. Because of random motion of electrons, net flow of electrons is 0, hence current is also 0 in figure 1. What happens in figure 1? Random motion of electrons, electric field is, no electric field is applied. Here E value is 0. Random motion of electrons, I value is also 0 because there is no net flow of electrons. Now come to figure 2. In figure 2, whenever we can set up electric field, how? And A is maintained at positive charge and B is maintained at negative charge. We can set up electric field by maintaining a potential difference. Now electrons will move. How long electrons will move? कब तक इलेक्ट्रिक फील्ड इनसाइड ए कंडक्टर रहता तब तक इलेक्ट्रॉन्स मूव होते हैं. दैट्स व्हाई वी आर गेटिंग करंट फॉर ए शॉर्ट टाइम. नाउ इन फिगर 3 वी वांट टू सी ए करंट फॉर अ लॉन्गर टाइम. बेटर यू कनेक्ट विथ ए बैटरी और सेल. वी कैन ऑब्जर्व द करंट फॉर अ लॉन्गर टाइम. ओके, थैंक यू. यू सी केयरफुली.